Let us now take a look at sensitivity analysis. Sensitivity analysis, abbreviated SA, is a technique to determine how different values of, for example, your independent variable will have an impact on the dependent variable under a given set of assumptions. With sensitivity analysis, we can verify which sources of uncertainty will contribute most to the variance, to the uncertainty of the model output. So basically, what will have the largest influence on my outcome? The sources of uncertainty in the model that we have can be either the model parameters, the initial conditions and the inputs, or the model structure. We will take a look at the model parameters. A sensitivity analysis will help us to better understand changes in the model predictions due to the above described sources of uncertainty. So it will help us to better understand the relationship between the outcome y and the parameters theta of the model. Furthermore, it can be used to check whether or not a model is robust. So what is the influence of outliers on my model? It can be used to reduce uncertainty. So by focusing our attention on a good estimation of the most influential parameters, we will be able to reduce the uncertainty in the model. And we can use it to simplify our model, so to perform a model reduction. So with sensitivity analysis, we can detect which model parameters will contribute most to the uncertainty of my model output. Therefore, if we want to reduce the model uncertainty, it is best to focus on the most influential parameters and then make sure that we got very precise estimates for these important parameters. Furthermore, it will give us an idea of the correlation between certain parameters, and it can help in choosing which parameters to estimate, and the parameters to estimate will be the ones with the largest variability. Sensitivity analysis will also give us information of where or when to sample, so it will give information on certain regions in space or time for which the model output is maximal, minimal, or meets a certain optimality criterion. It will be the basis for experimental design. It will give us information about which model parameters are unsensitive, so the ones that have very little influence on the outcome of our model. And so these parameters are less of interest and we will not bother too much in determining those. And it will be useful in model reduction of overparameterized models. There are two types of sensitivity analysis: a local sensitivity analysis and a global sensitivity analysis. For a local sensitivity analysis, we will look at the sensitivity at one certain point in our parameter space. So since we are looking at only one point, this type is not very computationally intensive. On the other hand, global sensitivity analysis will look at what happens or what the sensitivity is in a certain area of the parameter space. Usually we will then denote this through a mean sensitivity, so a mean over this area, and this can of course become a lot more computationally intensive. So for a local sensitivity analysis, on the left, we look at a fixed value of my parameter. So we look at a point in my parameter space and then we see what is the sensitivity at that certain point. For a global one on the right, we look at what is the influence or what is the sensitivity for an entire range of parameters, so for a fixed area, a fixed interval of parameter values. Each of the techniques has certain advantages and disadvantages, and they will give different types of information. So we cannot say that one analysis is better than the other, they are just different.